Hello everyone, this is Alistair here, and today's problem of the day is titled 7 segment display, and it asks us to use some form of greedy approach to solve the problem. Let's have a look at the problem itself. So in this problem, you are given a number represented by the string s, and the number of digits here is represented by the number n, and in this case 6 represents the string number count of the digits of the string s. Now every string here makes use of certain number of segments to get lit up. So for example, 2 makes use of 1 2 3 4 5 5 number of segments, 3 uses 5, 4 uses 1 2 3 4 4 segments, 5 uses 5 segments. Similarly, there are certain number of segments used by the digits 6 and 7. Now after doing this, we get the total number of segments used by the string s, or the number 2 3 4 5 6 7. Now our task is to generate a number such that the generated number makes use of the same number of segments that is being used by the string s, but also we have to make sure that this generated number is the least possible number. So in this case 2 3 4 5 6 7 had a total of 28 segments, and the generated number 0 0 0 0 1 1 also has 28 segments lit up, which means this is the final output that we can generate, such that this is the minimum number possible. Now, in order to understand how we can go over the problem, let's have a look at the example 2 3 4 5 6. So let's consider the string 2 3 4 5 and 6, and the number of segments used by each of these strings, let's write them down. So 2 here uses 1 2 3 4 5 5 segments, 3 uses 5, 4 uses I believe 4, 1 2 3 4, yep. 5 uses 1 2 3 4 5 5 segments, and 6 uses 6. So our total segments that has been used would be 10 14 19 25. Now since we have to follow a greedy approach, what I'll do in this case is that I'll create an array of size n, where n here in this case is 5. So I'll create an array of size 5, and I'll start placing all the array values with 2. This is because 2 is the only least possible segments that can be used to represent a digit, and that digit happens to be 1. Alright. Now after placing 2, what I'll do is I'll decrement my total count by the number of 2's present over here in this array. So I've used 10 number of segments, so I'll decrement 25 by 10, that would give me 15. After doing this, in order to generate the least possible number, I'll be starting from left to right, and I'll add all the starting positions with zeros, that is the number of segments used to represent zeros. And since 0 is represented by 6 segments, I'll add 6 here. But before doing that, we have to make sure that we remove this 2, and also remove this 2 from the total as well. So in order to do that, I'll simply add 2 over here, and I'll increment it by 6. That would reduce my total by a total factor of 4. So after adding 6 here in this position, I'll get the total segments used to be 11. Similarly, I'll add 6 over here, remove this 2, that would reduce my total number of segments used by a factor of 4 again, that would give me 7. Again I'll do the same. Now this will give me 3. Now if you look closely, I have total number of segments left to be 3, and I cannot add any more zeros over here because I do not have any more segments that I can use. In this case, the remaining segment is 3. Now I have to compensate for this 3 as well, right? So for that case, what I'll do is I'll simply add this 3 at the last position of my array A. So I'll add 3 over here, that is plus 3, that would give me 5, and I'll consider this 2 as it is. Now this is because if I add 3 over here, it would give me the segment value for this digit place to be 5, and if you look closely, 5 is being used by the number 2, 3, 5 and 9. And since we want the least possible value, if I place either 2, 3, 4, 5 or 9 in this position, it would not give me the optimal result. But in order to get the optimal result, I'll simply add 3 over here. This would give me 5 in the last position, and this would make sure that the generated array which carries all the segment values for the digit has the least possible value. Now if we convert these segment values to their corresponding digits, that is the segment value that corresponds to the least possible digit. For example, 6 here is also used by 8 and 0, but we'll consider 0. So we'll place 0 over here, also 0 over here, and 2 is represented by only one number, that is 1. So we'll place 1 over here. Similarly for 5, there are 3 possible outputs, that is 2, 3, 5 and I believe 9. Yeah, so we'll consider the least possible value, that is 2. So this generated result would be our optimal solution for the problem with the given string 2, 3, 4, 5, 6. Now let's jump right onto the code. So before moving on, we have to hard code the number of basically the number of segments used by each of these digits. So for that, I'll create an array of symbols which would give me the number of segments used by each of the digits as and when required. So 0 uses 6, 1 uses 2, 2 uses 5, not 3, then 4 uses, 3 uses 5, 4 uses 4, 5 uses 5, 6 makes use of 6, 7 makes use of 3, 8 makes use of, I guess, 7, and 9 makes use of 5. After doing this, we'll create a variable total where we'll store our total segments at any given point, and we'll also create another variable answer wherein we'll store a final result. Now we'll loop over the segments and calculate the total basically the calculate the total number of segments that has been used by the given string s. Since I have to convert the digit from string to the corresponding index value of this symbol, I'll simply make use of I'll simply increment my total value and get the corresponding segment value by subtracting the string with the character 0. After doing this, I'll get the total segments used. I'll create an array of size n wherein we'll be storing the segment value for each of the digits required. So I'll loop over this array, and initially we were storing 0. So I'll be doing that. Initially we were storing 2, not 0. So we'll be doing that now. So each time I add 2 in this array, I have to subtract my total by 2. After doing this, we'll now loop over this array again and start filling in zeros till a certain condition has been met, and that condition would be till my total is greater than equal to 4. This is because every time we add a 0 in place of 1, we are simply subtracting our total by a factor of 4. That's why we have to make sure this condition has been met every time we subtract it by 4. Also, there could be a case, for example, we have the total segment count to be 36, and we can keep on subtracting till we reach the end of the array. For example, if we had 6 digits, 1 2 3 4 5 6, and if we had total segments 36, then we can keep subtracting it by a factor of, I believe, 4, and we can keep adding zeros because 6 times 6 gives me 36, and in that case we'll be reaching the end of the array. So this is also one of the conditions that I have to consider. Now every time I'll increment my total and then add in my array value. I mean, replace the 2 with 6 and increment my, sorry, not increment but decrement my total by 6. I could do it in one shot, but I'll do it this way. Then I'll increment my I. After doing this, uh, there can be a case, for example, in this condition wherein we had some total segments remaining, that is 3 in this case, and what we decided was that we will consider this total segment remaining and add it in the last position so that we get the minimum number possible. So in that case, I'll take in the last uh, array value and I'll increment its value by the total remaining value. After doing this, now I'll simply loop over this array again, and every time I encounter a segment value, for example if it is 6, I'll store the string value to be 0, and if I encounter let's say 5, in that case I'll store the value 2 because the number 2 is the least possible number which makes use of 5 segments. And also if I come across the number 4, I'll since 4 is the only value which makes use of 4 segments, I'll add in 4 over here, and if I come across 3, not 3, we have considered 6, we have considered 5, we have considered 4 as well. Now we have to consider 3, right? Yeah, so we'll consider 3, and if that is the case, then I'll simply I'll simply add in 7, and if I come across 2, which can also be the case, in that case I'll add in 1 as the answer. Yep, that is it. So you've considered all the conditions. For example, if we had, in this case, we had 5 segments, right? So we considered 2. We are doing this in this case, in this condition. And if we come across, for example, let's say 4, then we'll add 4. And if we come across, let's say 3, that is we are adding one total segment. In that case, we'll get 3 segments. In that case, we'll add 1. And if we come across 2, then we'll add 1. Yeah, that's it. We have considered all the conditions. Now we'll simply return the answer. Let's try and compile. Alright, we got the right answer. Alright, so that was it for today's video. If you have any doubts, you can ask them in the comment section, and thanks for watching.